So hey guys, I'd like to remake my functional equation series. So actually, the problem I find is chosen from here. So here we have many functional equations for independent study. So I cannot find the solutions. So actually, I did work on it myself. So let's begin. This one for the problem one. It is a functional equation like this. So find all functions f from rational number to rational number that satisfies f of x plus y equals f of x plus f of y plus x times y. So the first step we can do is to substitute from the original equation. We can substitute x equals y equals 0. So this makes that for the left hand side it is f of 0 plus 0, which is f of 0. So on the right side, f of 0 plus f of 0 plus 0 times 0, which is 0. So in this case, we can cancel f of 0, f of 0. So this is 0. So it turns out to be f of 0 equals 0. So this is a good start. So for the next step, we can try to substitute y into x in the original equation. So in this case, for the left hand side, we have f of x plus x, which is f of 2x equals f of x plus f of y changed into x, so f of x plus x times x, which is x squared. Actually, you can simplify the right hand side into f of 2 times f of x plus x squared, but for this case, we don't really need to. So for the next step, still in the original equation, we substitute y into 2 times x. So on the left hand side, we have a f of 3x equals f of x plus f of 2x plus x times 2x, which is 2x squared. So, and then we repeat this procedure up to y is substituted into n minus 1 quantity times x. So on the left side, we have f of nx, because we have x plus n minus 1 times x, so which is nx. So on the right side, we have f of x plus f of n minus 1 x plus x times n minus 1 x, which is n minus 1 x squared. So we can just add this equation and n minus 1 equation together. So, and we know that we can make some cancellation. So we can see that we have f of 2x here, where f of 2x here, f of 3x, and then we will expect f of 3x here. And then finally, we have a f of n minus 1x, and we will expect f of n minus 1x here. So after making the cancellation, we can see that on the left side, only f of nx remain. And on the right side, we can count. We have totally n minus 1 f of x on the first column, and we have still another one. So we have totally n times f of x. So for the remaining one, which is 1 plus 2 plus ... up to n minus 1, all multiplied by x squared. So this is nothing but a algebraic sum. So it turns out to be n times f of x plus n times n minus 1 all over 2, which is the 1 plus 2 up to n minus 1. So multiply by x squared. So this is f of n x, and we may call this one equation 1 because we may use this one later. And we know that for this one it fits for n is a positive integer, and x can be any rational number. Actually, n can also be 0 because we have seen that f of 0 is 0. So if we just plug in 0 here, it also fits because of on the left hand side, which is f of 0. On the right hand side, which is nothing but a 0. If we just plug in n equals 0. So actually, up till now, we have already proved this one for x, n, not yet. So this is a very interesting one. This is actually an important one. So yeah, so here we can just let f of 1. We can just let f of 1 is a constant c. It's an arbitrary constant c. So in 1, we can just plug in x is 1. So on the left hand side we have f of n. And then on the right hand side we have n times f of 1, which is n times c plus n times n minus 1 all over 2 times 1 square. Okay, so we can we come up with this expression. For n is a positive integer, and also 0, and also 0. So our target is to prove f of x is c times x plus x minus 1 all over 2 for x is any rational number. So this is the one we try to prove. So now n is a positive integer or 0. I already proved. So the next step, whether we can prove it for negative integer. So the next step is to use the original expression. We just plug in y equals to minus x. Y, we change it to minus x as minus x. So on the left hand side we have f of x minus x, which is 0. So on the right hand side we have f of x plus f of minus x plus x times minus x, which is minus x squared. Okay, so on the left side f of 0 is nothing but 0. So we can have f of minus x is minus f of x plus x squared. So actually for this one we can just change x to be n. So in this case, we have f of minus n is minus f of n plus n squared plus n squared. So we can just make use of this not that make use of this one, make use of this one. So we can just plug in minus c times n plus n minus 1 all over 2. So this is f of n and plus n squared. So that we have a minus cn plus minus n squared over 2 and then n over 2 with additional negative sign, so we have plus n over 2 and then finally we have plus n squared. So it becomes minus c, or we may write it as c times minus n and then plus this one and this one. It becomes n squared over 2 and then plus n over 2. So next one we can just factor c times minus n plus n plus 1, 2. So this looks slightly different from what we try to prove. So actually we can just make it like, so we have minus n and then minus n plus 1, minus 1. Minus 1 all over 2. So you can check it like, here we have f of x, f of minus n, f of minus n. So we have cx, c times minus n, x minus n, x minus 1, minus n minus 1, all over 2. So here we also prove it for negative integer, which means that n is okay for all integer. So the next step is to prove when x is a rational number, which means n over m for n is integer and then m is integer. So we can make use of equation 1 and then we can plug in. Okay, for equation 1 we can plug in I can put here. We can plug in x equals to equals 1 over m. So on the left side it is f of n over m equals n times f of 1 over m plus n minus 1 over 2 times 1 over m squared. Yeah, so we make use of equation 1. So the next step is still using equation 1. We substitute x equals to 1 over n rather than 1 over m. So we have on the left side we have f of n times 1 over n, which is 1, and then equals n times f of 1 over n plus n minus 1 over 2 1 over n squared. So left side is c and then n times f of 1 over n plus it can just cancel n and then this one, and then we have 1 minus 1 over n over 2. So we can just slightly rearrange the term, so it will become 1 over n c minus 1 minus 1 over n over 2, something like this. So we just move this one on to the left side and then divide n on both sides. So it becomes 1 over n, or maybe I can just distribute. So we have a c over n plus c times 1 over n minus 1 and then over 2. No, it should be 1 over n. It should be 1 over n. So we can just plug in this one into here, so that we have a f of n over m equals n times this stuff. Actually, this equation is n, but actually we can just change this into m, and m, because it is just a dummy variable. So we have a c over m plus 1/2 1 over m times 1 over m minus 1. And then plus 1/2. So let me see. n minus 1 all over m squared. So we can just make some simplification. We have c times n over m plus 1/2 n over m squared minus n over m. So for the first two term and then for the second two term, we have plus n squared over m squared minus n over m squared. So we can make some cancellation, cancel this term and this term. So let me see. So the remaining term is this one. So we have a c times n over m plus 1/2, and then we can just factor n over m out, and then we have n over m minus 1. So let's compare this with what we want to prove is here, f of x, maybe I use this color, f of x, we have f of n over m, and then c times x, c times n over m, 1/2, and then x, n over m, x minus 1, we have n over m minus 1. So we already proved it for any integer, because for this one, for equation 1, n is already any integer, it's okay. For equation 1, n is integer, it's okay. So the equation one for this one, n is integer is okay, so we make use of this. So n over m is any rational number. So for the last step, we can try to check if this fits for f of the original equation, which is like this, plus xy, and then we have f of x equals to c times x plus n minus 1 all over 2, or you can not n, here it should be x minus 1, or you can slightly rearrange the term like the x squared over 2 plus c minus 1/2 multiplied by x. So in this case, we can just plug in for the left hand side of the original equation. It will be x plus y over 2 squared plus c minus 1/2 multiplied by x plus y. So this is the left hand side. For the right hand side, it will be x squared over 2 plus c minus 1/2 x plus y squared over 2 plus c minus 1/2 x y. Plus xy. So we can have this term, and this term to become x plus y squared over 2. So this one is this one. And then for this term and this term, we can just factor c minus 1/2. And then we will have this x plus y factor. So we verify that this one is our final solution. This one. So this is the end of this video.